This is 5-3. Your sister came and got it yesterday.
She asked me, she said, does Milbrath teach Japanese? If so, I want to take Japanese.
She should have just said yes. Yes, he does.
And yesterday you handed me like the whole rest of the stack of homework. Like, so it's like 50 of the same copies.
That was elsewhere. 45. So you're supposed to find a rational function that might have the given graph. This thing has a 0. It's at x equals 0. What's the factor that creates x equals 0? It's literally this piece right here. Factor is just an x. This is a touch too. I kind of alluded to this yesterday, but that is a touch. How many times does a touch happen? Remember from Algebra 2? That's a touch. Happens at least twice. So it could be x squared. Rational expressions are kind of funny looking, but it could very well be x squared as well. Let's see what happens here. We have a horizontal asymptote and y equals 1. And we have two vertical asymptotes. The vertical asymptotes are at -2 and +2. Now, what factors will create those vertical asymptotes? That's right, they're created by x plus 2 and x minus 2. So that's just going to go down in the denominator, x plus 2 and then x minus 2. And up top, I'm just going to put the x. And this is why I mentioned that that could be x squared. If we do near math down low, we have x squared, don't we, if we did some FOIL method? And we'd have x over x squared. That does not have a horizontal asymptote at y equals 1. X over x squared has a horizontal asymptote at what? I'm trying to get to somewhere. I'm trying to tell you need more up top. What you have written is x over x squared if you just ignore the numbers. Do you get that? Where is its horizontal asymptote? The degree of the denominator is greater than that of the numerator. Where is its horizontal asymptote? That's cool. Y'all look it up. I wanted to take a bite anyways. That's right. I didn't even get my bite. So y equals 0. This isn't the function. You have to create a horizontal asymptote at y equals 1, which means the degree of the numerator has to match the degree of the denominator. So that's why I mentioned that a touch happens at least twice. That is actually x squared. Because now you have x squared over x squared. Who cares about the numbers? That's what you have. And x squared over x squared reduces to y equals 1, which is exactly where your horizontal asymptote is. So this could be your function. There could be a number in front of it too, but that has all the properties of that graph. And that is number 45. What you got, Brent? 40. Another graphing section. Yep. There's probably other ways of doing this, but I'm going to add the pieces together. You remember how you add fractions? Yeah, but there's kind of a shortcut too. Like if you do 1/2 plus 3/4, you do 1 times 4 plus 3 times 2, sitting over twice a 4. That makes the denominator common. That makes the denominator 8. And you multiply the 1 by the 4 because you multiply the 2 by the 4. Multiply the 3 by the 2 because you multiply the 4 by the 2. That's how you add fractions, kids. So I'm going to give this x, this 2x, the x. I'm going to give that 9, the understood 1. And the unified denominator is just 1 times x. So after I clean this up, I'd have twice x squared plus 9 sitting over x. Where's its vertical asymptote? Vertical asymptotes happen when you divide by what? So where is its vertical asymptote? Let's add x equals 0. Is there a horizontal asymptote? No, because the degree of the numerator is 1 higher than that of the denominator. There is none. Is there a slant? There is a slant asymptote. Slant asymptote happens when the degree of the numerator is exactly 1 higher than that of the denominator. You know how I know all this stuff? I memorized it. Do you know why you don't know it? You didn't memorize it. That's what it boils down to. It's just memorization. How do you find a slant asymptote? What do? You do long division. And it won't be with one step. I can look at this one and tell you what it is. I'm going to put a placeholder. 2x squared plus 0x plus 9. How do you turn a x into 2x squared? You 2x it. You subtract, the 2x squareds cancel. Now all you have left is 9. You're done because that 9 represents what? Remainder. So there's your slant asymptote. 2x, y equals 2x. And now I'll graph. There's a vertical asymptote at x equals 0. But all I can do is dash that out. There's a slant asymptote at y equals 2x. Where's that thing cross at? Crosses at 0 and wants its slope. So rise 2, run 1. There's my slant. I forgot to find it, but you talk about zeros. You said 2x squared plus 9 equals 0. Is it going to have any zeros? Why not? If 2x squared plus 9 is 0, does it have any zeros? Kids, it's 3 steps. You subtract 9, you divide by 2. Don't even worry about what the numbers are. Subtract 9 and divide by 2. Are you positive or negative? You're negative. You're going to try to take its square root. Is that real? No. Does it have any zeros? No. There aren't a single zero on this thing. The rest of this thing is make tables. Make tables. I have no idea what this thing looks like, but I'm probably just going to plug in a -1 and a -2. Part of me thinks there might be something happening in here. My guess is it's going to come from up high and then aim towards that asymptote, that slant asymptote. And it's probably going to come from down low and do something too. So I'm going to go ahead and plug in 1, 2, and 3 and see what happens. Oops, I don't know why I went to y equals. That'd be the easy way, wouldn't it? -1 stored to x. That was a 2x to the second plus a 9 sitting over an x. So -1 is actually -11, which is way down here. Makes me want to do something like -0.5. So I'm adding to my table. So -1 is -11, -2 is -8.5, which I really can't even grid out. Three is -9. This is a funny looking graph. A very funny looking graph. What's 1? 1 is 11. 2 is 8.5. 2 is 9. 4 is 10.5. Yeah, the right hand side of this graph is doing this. And the left hand side of this graph is doing this. You'd probably have to look at a calculator to see that, but that's what it's doing. It's doing something kind of funky. International graphs are funky. But anyways, that's that one. Don't worry, you'd never have to graph anything that hard on a quiz. What else you want to see? It's like two weird little parabolas trapped inside asymptotes. That's all it really is. Anything else you care to see? What number? 54. Problems like that are probably best when you have a big grid and you can plot lots of little decimals. Oh, we got ourselves not even really a word problem. So the surface area of a UPS. UPS is contract you design an open box with a square base that has a volume of 5,000 cubic inches. Express the area S of the box as a function of X. So how many faces does this box have? It has 6 faces. So your surface area, first off, you got to realize it's 6 squares. Right? 6 of them. Now, 2 of those squares, the top and bottom, have dimensions x by x. So they're just x squared. I hope you understand that. Top and bottom is x by x, so x squared, and there's 2 of them. The other 4 are all x by what? Y. So plus 4 xy's. That's how you find the area of a square. You multiply side lengths. So there's an equation for your surface area. It's not the goal, though. It's right now it's written in terms of x and y, and the goal is to write it in terms of x. Well, they tell you the volume. Now you find volume. Length times width times height works. So it's x, x, y. Because length and width are x and the height is y. What do you know about that volume? It is 5,000. If you were to solve this equation for y, could you eliminate y over here through substitution? That's the goal. Divide both sides by x squared. There's your y value. So now you have your surface area as a function of x. It's 2x squared plus 4x times 5,000 over x squared. As simple as that one is to clean up, we'll clean it up. That's all we'll do with it. Thankfully, it says use a graphing utility. So that was A. B is done in y equals. Assume 6 is probably worthless. And it is. So I'm going to go on the hunt. I'm going to look up 300 units, and I'm going to look to the right about 20 or so. See if I start seeing anything. And I saw nothing. Because, for one, I put the function in wrong. Still saw nothing. 2x squared plus 2,000 over x. The area of each of these rectangles here is x times y. How many of them are there if you go around the box? Well, I made a mistake too. 4 times 5,000 is 20,000, but x over x squared is x. I actually didn't write something right on a piece of paper. I'm expecting to see this graph, but I'm not. That seems a little pushing it. No, that's what it took. So I had to play with the y-max all the way up 2,000 before I ever saw it. I'm actually going to look to the right 40. Now, I've actually seen what it's asking for in part C. What's part C ask for? You know what you're saying? Is that not what you're seeing? It looks like a minimum to me. Looks like the graph's up high on both sides. It's a minimum. So second trace 3, get left, get right, and enter for a guess. It says that x is about, they don't even tell us how to round, do they? We'll say 17.1 inches. Now that's x. Y was 5,000 over x squared. So it's 5,000 over that 17.1 squared. Y is also about 17.1. Makes sense to me. Most efficient rectangular prism is probably going to be a cube. That's kind of what that's saying, isn't it? Alright, so we answered actually, I'm kind of an idiot here. We answered D right here. This was part D. Part D was the dimensions. Part C was the amount of cardboard used. The Y value, 1754.4 square inches. And part E is why might UPS be interested in designing a box that minimizes surface area? Uses less cardboard for one. Probably packs better in the vehicle. They're all the same size. And there's lots of reasons. I need to stop there. I'm going to start on number 21. By the way, do not train yourself for a multiple choice test. Okay? Especially with this many kids out, I'll probably have to have them take it at home, so it'll be show all your work at a bare minimum. So don't train yourself for a multiple choice test. Which of the following functions could have this graph? It's kind of like the homework problem that we did. This thing has two zeros. It has a 0 at x equals 1, and that's a touch, which we talked about when we went over the homework. How many times does that thing happen? At least twice. We also have a 0 at 3, 4, 5, 6 at x equals 6. That's a crossing. How many times that happen? A touch happens at least twice. A crossing happens at least once. The even ones, the touches, they can be 2, 4, 6, 8 times. The crossings, they can be 1, 3, 5, 7, 9 times. They happen an odd number of times. Touches happen an even number of times. So we'll use the word at least in these. So anyways, our numerator is kind of locked in stone to some degree. The factor that creates x equals 1 is x minus 1, and it's going to happen at least twice. Sorry, that 0 is not at 1, it's at 2, isn't it? Happens at least twice, so it's x minus 2 squared. And the crossing that happens at 6 is x minus 6. So what does that eliminate for us? If that's what our numerator has to be. Does it eliminate choice C? Yeah, choice C is gone. Anything else? It eliminates D. Now we're going to focus on our vertical asymptotes. I see one at x equals negative 1 and x equals 4. Now what that does is that gives us our denominator. Our denominator's got to be x plus 1 times x minus 4. Maybe, maybe not. If you did some near math on here, this is about x cubed over an x squared, isn't it? Isn't that what that is? What kind of asymptotes that have? That's a slant. Do you see a slant? No. One of these terms down low has to be squared. One of them has to be squared, which you see in B and D, or A and B, don't you? That they've squared the -4. So that kind of comes from looking at the answer choices there. One of them had to be squared. Which one? Probably didn't matter. Now, the big difference between A and B is A and B both talk about horizontal asymptotes. This one has a horizontal asymptote at y equals 2. And where's this one's horizontal asymptote? I told you yesterday when I did your notes, that number out front is where you find a horizontal asymptote. So that one has a horizontal asymptote at y equals 2. Where's the other one's horizontal asymptote? Y equals 1. I wonder which one's right. Here's y equals 1. There's y equals 2. Kind of 50-50, isn't it? It's okay to cross a horizontal asymptote, isn't it? Only if it comes back up. It's B. You can. Close to the origin. And you still are close to the origin. But what they will do is they will cross and they will come back to the other side. When you cross a horizontal asymptote, you will go beneath it and then you'll come back up. And that one has shown no evidence of doing such a thing. So that question's a little bit on the tricky side. The key might even say, hey, wouldn't surprise me if it did. No, it says B. But generally speaking, you don't cross. All right, so that was 21. What's 20? 20 is a graphing function. I'll label what I want to see. I want to see the zeros. Well, where do zeros happen? Up high or down low? Up high. So you literally take x to the fourth minus 1 and you say it equals what? 0. You could probably solve that through factoring, but we're just going to add 1 to the other side. And how do you counteract a fourth power? Fourth root. So x is 1 to the 1/4, or maybe if you like the radical 4 with a 1. I don't really care. How many answers that thing got? 4? No, it doesn't have 4 answers. It has 2 answers. They happen to be both repeated. 1 times 1 times 1 times 1 is 4, isn't it? Or sorry, 1. What else is also 1 multiplied by itself 4 times? -1. This is plus or minus 1. Your calculator won't tell you the plus or minus symbol. It's where your brain comes into play. So there's a 0 at +1, there's a 0 at -1. The vertical asymptotes happen when the denominator is not 0. You can factor that one if you want, but that's x minus 5 and x plus 5, not 0. So I know that x is neither -5 or is it 5. So there's my vertical asymptotes. Horizontal asymptote, does it have them? Does it have a horizontal asymptote? Why not? There's more up high. Horizontal asymptotes happen when the degrees match or the bottom is higher, because the bottom outruns the top. This one doesn't have a horizontal asymptote. Does it have a slant asymptote? None. Why not? Yeah, the numerator is 2 degrees higher. The deal is you can only be 1 degree higher. And I have never heard of a quadratic asymptote. I'm not saying they don't exist, I just haven't heard of them. They probably do exist. I've just never heard of them. Now, how are we going to fill out the rest of this crap? You're going to make what? You're just going to make a table. I understand, it's kind of boring. I wouldn't plug too much in. Maybe -6 and -8. The -6, though, I'm not even worried about -6. This was at -5, right? So -5.01, -4.99. Stay close to that asymptote so you can see its behavior. I guess maybe we'll do a -3. I'm a little curious what happens at 0, but I can look at the graph there. I can look at the equation. Maybe a +3, 4.99, and 5.01. Just those numbers right there. Now, do you guys need to watch me plug in numbers? That's the deal, just make up a table. We have a word problem in 19. A rare species of insect was discovered in the rainforest of Costa Rica. Environmentalists transplant the insect into a protected area. Population of the insect T months after being transplanted is given as followed. I made this mistake yesterday, so be careful about that. T months, right? What's the population when T is 0? What are you going to replace T with? I feel like you ought to be able to look at it and figure that out. So this 0.6T is gone, isn't it? This 0.02T is gone, right? You're left with 45/3. That's all you're left with, which is 15. After 10 years, what are you going to have to let T be? 10 years, but 120 what? Months. Remember, the equation talks about time in terms of month, not years. So you got to remember that piece. That's an easy thing to forget. So what's the numerator here? 45 plus 0.06 0.6 times 12. We got 369 up high. The denominator, 3 plus 0.02 times, why did I use 12? What was I supposed to be using? 120. 3285. The denominator, 3 plus 0.02 times 120. 5.4. Now, why anybody would want to protect a species of bug is beyond me. And if it came from Central or South America, it's probably something that bites or stings. 609. Like if red wasps, like everybody wants to care about the environment. How many of you would care if the red wasp would disappear? Is there anybody in this room who cares if that bug exists? No. Not even the biggest tree hugger alive cares if the red wasp disappears. So it's about preference there. What is the largest value the population could reach? I don't remember if you remember this in the homework problem yesterday, but I think they're kind of looking here for a horizontal asymptote. That's what they're looking for. What I'm going to do is I'm going to do a little distribution here. I don't think this is quite, let's see, the population. No, I'm going to distribute. 6 tenths 45, 5 times 6, 24, 27. That's a case where the degree of the numerator and denominator match. So we throw away the numbers. All I did was the distributive property. I wanted to see if this thing written out in terms of t's. So I'm going to take 27, I'm going to divide it by 0.02, which is like multiplying by 50. And I'm going to get 1350. And to prove that idea to you, I'll take a look at the graph of this thing. Because I know, me just telling you that's where it happens probably doesn't make a lot of sense. Let's see, I'll need to look up at least 2000. And we'll look right about 20 years, 240 months. Oh wow, it didn't even get there in 240 months. Well, that is the max population you can have. Did I make a typo? I don't see one. Well, that's what it is. It's kind of interesting here that that's at 609. My equation's not showing that number pop up. 45, 1. Ah, that's why. Typo. And I'm thinking that we have a 1350, so I'm going to put that in Y2. I went out 480 months here. Let's do 600 months. Yeah, I'm going to have to go farther. Go 900 months out in the future here. Still hadn't hit that sucker, has it? Okay, 2,000 months. Yeah, we're starting to get there. You see it leveling out? 2,000 months, that's a long period of time. More than you or I will be alive. Yeah, it's still working backwards. See one of your more mystical types of questions. Can in the shape of a right circular cylinder is required to have a volume of 700 cubic centimeters. So think back to your Coach Snow days. How do you find the volume of a can? That's how you find volume. Area of the base times the height. That's what volume is. It's a cylinder, it's a can. What's the base? Pi r squared is a circle. Pi r squared h. That's how you find the volume of a can. There's more to it. The top and bottom are made of material that cost 8 cents per square centimeter, while the sides are made of material that costs 5 cents per square meter. Which function below describes the total cost of the material as a function of the radius r of the cylinder? So what they're actually talking about was what it takes to make. They're actually talking about surface area too. The material that makes the can. So there's more to it. I don't know if your geometry teacher ever did this with you, but if you were to take any sort of cylinder and cut it into its three pieces, this would be what you call its net. That's the net of a cylinder. You've got a rectangle wrapped around two circles. This will be my height. About all I really need for the circles is radiuses. The width of this rectangle, it's actually the length. It's usually actually longer. You don't realize that, but it's wrapped around this circle. How do you find it if it's wrapped around that circle? Circumference, that's right. It's a shame you don't really like to do more math work. What was that Taylor that said it? Was you? You said 2 pi r, right? Which is 2 pi r. Like I said, it's a shame you really don't apply yourself. You were really bright. How many of the rest of you realized it was going to be 2 pi r? See? It's a shame you don't apply yourself. Well, there's what we need. I know the volume is 700. When I start talking about the surface area of this thing, I'm actually going to have two different pieces here because of the material that it takes to make these things. Because it's also about cost, the cost of the surface area. The circles cost 8 cents per square centimeter, 0.08, and that's just area, pi r squared, and there's two of them. The rectangle is 5 cents, 0.05, 2 pi rh. That would be a cost function. 8 cents times pi r squared plus 5 cents times 2 pi rh. Now this is a two-variable equation. Can't have that. How many variables can you have? One. So that's where that volume was given for. That's why it was given. Do you want to solve the volume for R or H? H is the easy one. H is 700 over a pi r squared. And we'll just put that right there. I'm going to do a little math here too, because you notice they've got this nice reduced function. Twice 0.08 is 0.16 pi r squared. So I'm looking for a 0.16 pi r squared. B and D are gone. Those are 0.08. 2 because there were two circles. Plus 0.05 times 2 pi r and an h 700 over pi r squared. Now those pi's are going to cancel. One of the r's is going to cancel. 0.05 times 2 is 0.1 times 700 is 70. I'm going to have 70 over r there. Choice A. I guess I won't give you a test tomorrow. I am going to go over this review with you in the hopes that you at home watch the video. Yep. When you got this many kids